Welcome back to Lesson 4, Comparing Ratio Relationships. For this lesson, the objective is that students will use graphs and tables to compare ratio relationships. The good news is you don't have any new vocabulary terms. While there is some vocabulary located in here, such as equivalent, compare, and ratio, all these are terms you should already be familiar with. So we have no new vocab to get over learn today and write down, so we're going to start straight with launching the presentation. So, Chapter 1, Section 4, Compare ratio relationships. Student councils sometimes hold fundraisers to raise money to purchase new items for students and the school board building. Often, fundraising companies will give a certain dollar amount back to the group based on the total amount sold. For example, a company may advertise that they will give the group $1.50 for every $15 worth of product sold. This benefits the whole group selling items and the company producing the items to sell. There are many different fundraising opportunities that will work with various groups to help them raise monies they need. When selecting which company to use or what products to sell, it might be helpful to compare the ratio relationships between the companies so that the group doing the fundraising benefits by earning as much money as possible. Now, I know this might seem kind of strange to y'all because since COVID started, we haven't really been doing that kind of fundraising. But hopefully someday COVID will end and you may be asked once again to sell magazines or candy bars or something like that to help raise money for school. Our Talk About It section says, suppose 3 different fundraising companies are using ratios to show the amount of money they will give a group per certain dollar amounts of products sold. How might you begin to organize this information? Once the information has been organized, how might you compare the ratio relationships in order to determine which company will give the greatest amount of money to the group? And that's kind of the whole point of this lesson, is to figure out how we can organize this information and then compare it so that we can figure out who is going to be the biggest bang for our buck. One way that we can do this is by using graphs to compare ratio relationships. Ratios for ingredients of dog food vary among companies that manufacture dog food. Company A advertises 25 grams of protein for every cup of dog food. The relationship between protein and cups of dog food for 2 other companies is shown on the graph. You've got Company B is showing their ratios here as a table, and Company C is showing their ratios here as a bar graph or a line plot. This is 3 different representations of the data. One of them just gave you a number, 25 grams for every 1 cup, and the others gave you a what do we call this? A ratio chart. And this one here gave you a graph. And you've got to be able to look at these 3 different companies and figure out how to compare them so that they can be the best. Simply put, we need to convert them all to the same language. They either need all to be set to a unit rate of 1 cup, or the same type of chart table, or the same type of graph. So, what do we know? We know Company A has 25 grams of dog food. We know Company B has that chart of information, and we know Company C has that graph of information. From here, we can note that the ratios of each of the 3 companies is shown using a different representation. To compare them, we can use the same representation such as a graph. Like I said a minute ago, you need to convert them all to the same type of chart. So they plotted the points for each of them on the chart. In Company A, they only had 1 point to start with. They only had 25 grams for 1 cup. So from there, they would have projected that, okay, well, 2 cups then would be 50 grams, you can see on the blue line, and 3 cups would be 75 grams, also on the blue line. Now the company B is our green line, and they gave us 3 point values here that you can see graphed. And then company C, that's the one they gave us to start off with. So you can just take a quick look at that graph, and you're going to see that company A is the steepest line. It goes up higher, quicker than the other two companies. You can also see that company B is a steeper graph than company C. This means that company A is going to have the greatest ratio of protein to cups of dog food. Company B, well, they're going to come in second place. And you know what we call second place, right? Second place is first loser. Moving to our next slide. If the ratio compared cups of dog food to protein, how would the graph have changed? Which line would then be the steepest? Well, let me stop and think about that one for a moment. You guys need to be thinking about it too. I'm thinking that if you were to flip it, instead of comparing protein to dog food, we were comparing dog food to protein. At that point, the steeper of the graphs would be company C, because it would take more cups of dog food to equal the same amount of protein. Moving forward, use graphs to compare ratio relationships. Paulo's Pizzeria advertises 24 pepperonis on every 12-inch pizza. The relationship of pepperonis to a pizza size for two other pizzerias is shown on the graph. Which pizzeria advertises the greatest ratio of pepperonis to pizza? So you have got slice of pie pizza is going to be your second one that you see right here on the table, the ratio table. And then you have the pizza place. What a really lame name for a pizza place, shown on a graph. You need to take and study the three, figure out what's the best way to represent the data so that you can determine who is going to have the most pepperonis on the pizza. Moving from there, let's figure out what we know. We know that Paulo's Pizza has 12 pepperonis for every 12-inch pizza. That should be 24. We know Slice of Pie does, their pizza slice is 10 inches for 15 pepperonis. So that's important to notice, is that this is backwards from this one. This one lists pepperonis first and then pizza size. This one lists pizza size and then pepperonis. That's the place that might trip us up. And then the Pizza Palace has the pepperonis on the vertical axis and the pizza size on the horizontal axis. Compare the three ratios. Use the same representation for each, such as a graph. And there you have your data. You pause the recording from here, create yourself a graph so that you can figure out what is going to be the best deal as far as getting the most pepperonis on your pizza. When we made the graph here, it ended up looking like that. Does your graph look like that graph? Where the pizza place turned out to have the most pepperoni per pizza. Then next after that was Paulo's Pizzeria, followed by the Slice of Pie having the fewest pepperonis for pizza. And while pepperonis is important, it's all about the pizza sauce, guys. Love Papa John's. Papa John's got the best chain pizza going. But there's two other great pizza companies I've been to. Little hole-in-the-wall shops. One of them is Sharky's Pizza in Charleston. If you're ever in downtown Charleston, go to Sharky's. And the other one actually had a movie made about it, in which Julia Roberts, I think she was 15 years old at the time, starred in the movie. That movie is, of course, Mystic Pizza in Mystic, Connecticut. Both of them, outstanding pizza. Great places to eat. But we're not talking about places to eat pizza right now. We are talking about the ways to do math and compare pepperonis on the pizza. Moving forward, you can see here once again, there's our chart. Now I want you to pause the recording and answer the questions that are contained therein. All right, my turn to answer them. That means that blank has the greatest ratio of pepperonis to pizza size. So who has the most pepperonis? That's my blue line to pizza size. That's going to be Pizza Palace. So I'm going to select Pizza Palace there in inches, followed by, who's the next one? That's going to be the green one, Paolo's Pizza, and then the loser is going to be Slice of Pie. From there, we're going to check our answers, and everything checked. Excellent. Moving forward, how many more pepperonis would be on an 18-inch pizza from Pizza Palace than on an 18-inch pizza from Paolo's Pizza? Take a minute on your own, write it out, figure out a good way to calculate it. I'll give you a hint. Use the graph. Alright, hopefully you paused it. To do that, I'm going to just use my graph. I'm going to start with the 18 inches right here. And I want to say that Pizza Palace 18-inch is going to be my blue line. And there is 45 pepperonis you can see up here on the 18 inches pizza from Pizza Palace. Meanwhile, Paolo's Pizza is going to be the green line. And that is going to be, looks like about 36. So how many more pepperonis would be on the pizza? Let's see if they give us something to work on with that. It's got to check. Is it going to load right? It's not going to load right, I don't think. These usually don't. So we're going to skip back on that. How many more would it be? That is going to be the 45 minus the 36. Let's make a screenshot of that. So right here, we're going to mark it up now. On the 18, that's right here. We got this point right here, which was a point for about 45. And then on Paolo's Pizza, been that point right there, which I'm going to say is about 36. The question wanted to know how many more pieces of pepperoni it would be. All we have to do there is take 45, subtract 36 from it, which does mean you're going to borrow. 4 becomes a 3, the 5 becomes 15. 15 minus 6 is going to be 9. So you end up with 9 being the answer to the question that's being asked right here. We're going to pause to skip forward to the next one. All right, our next question's ready to go. The relationship of pepperoni pizzas to the pizza size for the 3 pizzerias are shown, just like it been. But now, another pizzeria named Small Town Pizza advertises 33 pepperonis for every 12-inch pizza. So we've got our chart for the 3 that we worked with. We want to take and figure out now, we got this new player in town, which is Small Town Pizzeria. Let's go ahead and highlight that. And they have 33 pizzas on pepperonis on a 12-inch pizza. Which pizzeria now? Small Town Pizza, the Pizza Palace, or the Pizza Palace advertises the greater ratio of pepperonis to the pizza size. You pause this recording and you spend some time thinking about it and answer the question and check your answers. So what did you find out? Well, once again, I'm going to take a screenshot here. And with my screenshot, I can now write on it. And we're going to take and we're going to look at the Small Town Pizza. Said that it has 33 pepperonis for every 12-inch pizza. So I'm going to start on my 12-inch pizza size. And I'm going to go up. Well, that's 30. So right here, 33. That's going to be about that point right in here somewhere. So which of the pizzerias, Small Town Pizza or the Pizza Place, is going to have a greater ratio? Well, the Pizza Place is a blue one. Small Town Pizza is my new dot. Small Town Pizza is going to be the winner. So I'm going to go back to my computer screen. I'm going to hit Small Town Pizza and check the answer. And the answer is indeed going to be correct. Great job. Alright, new problem. Use tables to compare ratio relationships. Another way to compare a ratio relationship is to use tables, apparently. For example, a comparison of 3 smoothie recipes shows that recipe A has a blueberry to strawberry ratio of 8:2, and you can see that right here. ratio B has a ratio of 5:1 that you can see right here, and ratio C has a ratio of 10:3 that you can see right here. You can use tables of equivalent ratios to determine which recipe has the greatest ratio of blueberries to strawberries. Use scaling to write equivalent ratios for each recipe. You can compare the ratios and when one of the quantities in each of the relationship is the same. So let's take just a for example here. A for example, and let me get a screenshot. Alright, a for example shows that right here recipe A and recipe B has some common points. For example, I have 2 and 2 for strawberries on recipe A and B. So which one is going to have the most more blueberries to strawberries? Recipe B is, because you have 10 here compared to 8 there. Likewise, we could also compare the 4s and we can compare the 6s. Each one of those is a good place to look to find out who is going to have the higher ratio of blueberries to strawberries. Going back to our problem, you can see that it says ratio B has 30 blueberries to every 6 strawberries, followed by recipe A with a ratio of 24:6 and recipe C with a ratio of 20:6. So they took and compared all 3 of them to where they had a bottom number of 6. You can see them listed in orange there. 24:6, 30:6, and 20:6. So recipe B had 30 to every 6. They're going to be the most blueberries to strawberries. Recipe A was 24 to every 6. And then if you don't like blueberries, recipe C is going to have the fewest, 20 blueberries to every 6 strawberries. Or think about a question. If the ratio relationships were graphed with blueberries being the y-axis and strawberries being the x-axis, the line for which recipe would be the steepest? Explain. I want you to stop and take a minute, pause your recording, and write out your explanation. All right, going back to what we looked at, we found on this chart that B had the most blueberries compared to strawberries. Blueberries were our y-axis, strawberries were our x-axis that you can see here. Therefore, recipe B was going to have the steepest line of the lines that we're looking at here. Alright, that's going to be the end of part 1. I'm breaking these down into smaller pieces so we can come back and kind of make it more bite-sized, and hopefully your iPads won't die trying to watch them. And we'll come back and watch part 2 in a minute.